Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. N is a two-digit positive number. It is also a prime number. What is the value of n? And this is a data sufficiency problem that's commonly asked in standardized tests like GMAT. And we are given two statements. The first statement is the number obtained by reversing the digits of n exceeds n by 9. And the second statement is that the sum of the number n and the number obtained by reversing its digits is divisible by 13. And then we have to pick the best choice from options A through E. And for us to be able to do that correctly, we need to evaluate the two statements alone meaning treating each one independently as if the other doesn't exist. And then in some problems, we got to consider, what happens if we have both of the statements available as true. And that's how we kind of evaluate the data sufficiency condition. So in this particular problem, we start by assuming that the digits in the tens place and the units place are x and y for the original number. So a two-digit number has a tens place and a units place, right? So we assume that in the original number, the digit in the tens place is x, the digit in the units place is y, and this makes the value of the number, it's not xy, the value it's not xy because xy is a product, right? So what will the value of this? The value of this will be basically 10 into whatever digits in the tens place, which is x in this case, so 10x, and then 1 multiplied by whatever digit is in the units place, which is y. So it's 10x plus y. So we are given that this number is prime, and we know that there are many two-digit prime numbers. So this alone, of course, doesn't specify what's the value of n, but it's a condition that we have to keep in mind, that this number has to be prime. What happens when we reverse the digits of the number? Well, we still get a two-digit number, but now in the tens place, we have got y, and in the units place, we got x. So it's swapped compared to the original number. And then the value of this number by reversing the digit, that comes to 10y plus x. Now it's time to consider the two statements. So let's consider the statement 1 by itself. So it states the number obtained by reversing the digits of n, so that's 10y plus x, exceeds n by 9. So n is 10x plus y, so it exceeds 10x plus y by 9. And we can write this equation from this statement that 10y plus x is equal to 10x plus y plus 9. And then from this equation, it's easy to obtain that 9y minus 9x is equal to 9. And then if we take 9 common and divide both sides by 9, we get y minus x is equal to 1. Now, for y minus x is equal to 1, so y and x are the two digits, right? We can actually find several combinations. We do some trial and error for which the original number, which was 10x plus y, with x in tens place and y in units place would turn out to be prime. And these are some examples. If we have y equal to 3, x equal to 2, y minus x is still 1, which is what we derived based on condition 1 or statement 1. And for this particular values of y and x, our original number is 23, which is a prime, right? But this is not the only prime number which satisfies, the given condition from statement 1, or the derived condition from statement 1, which is y minus x is equal to 1. There are other prime numbers as well, and these are some examples. If y equal to 7, x equal to 6, we get n equal to 67. That's a prime number as well. And then we have one more, y equal to 9, x equal to 8, which makes the number 89, which is also prime. So condition or statement 1 by itself doesn't uniquely specify a particular value of the original number n. So now let's consider statement 2. And this is a consideration that's independent. So it's independent of whatever was given in statement 1. So statement 2 states that the sum of n and the number obtained by reversing its digits is divisible by 13. So what would be the sum of the number n and the number obtained by reversing its digits? It's simply 10y plus x plus 10x plus y. And we don't know what the sum is, but we know that it's divisible by 13. So I just wrote it as 13k, where k is some positive integer. So this sum is a multiple of 13. And then if we, further do the addition on the left hand side, you basically end up with 11y plus 11x is equal to 13k. And then if we take 11 common, we have 11 multiplied by, within parentheses, we have y plus x is equal to 13k. Now 11 is a prime number, and obviously it's not a factor of 13, right? So if 11y plus x has to be a multiple of 13, then y plus x has to be a multiple of 13, right? But remember that x and y, they're digits of a two-digit number. So the maximum value that x plus y, the sum x plus y can take, the maximum possible value is 18, because each of x and y has to be less than equal to 9, because they're digits of a two-digit number, right? So they cannot exceed 9. So the max out, if I max out the sum, the maximum possible sum x plus y would be 18, right? So it has to be less than or equal to 18. But if it's a multiple of 13, then the only multiple of 13 that's less than 18 is 13 itself, because the very next multiple of 13, which is 13 multiplied by 2, that's 26, which exceeds 18. So from this we can write that x plus y must be equal to 13. And if that's the value of x plus y, well, what are the possible pairs of digits whose sum adds up to 13? So if we think about that, we can actually write the potential, possible pairs of numbers. So it could be 49 or 94, 58, 85, 67, 76. And these are the only possible pairs. So such that the digits, they add up to 13. And if we examine all of these, there's actually only one number among these pairs, looking all across these pairs, which is a prime number, and that's 67, right? So that's the only prime number. So going by condition 2, and so far we've been using condition 2 alone. We haven't been actually, in this particular exercise, after we were done with condition 1, we were only using condition 2 and treating as if condition 1 didn't exist. So far in the condition 2, we haven't utilized any of condition 1. But by using condition 2 alone, we are able to uniquely specify what the value of n will be. So going through all the options from A through E, the correct option will be option B, which states that the statement 2 alone is sufficient, but statement 1 alone is not sufficient. So that will be the best choice in this particular problem.